on which you are going to analyze the stability. We have modern setup like total station. It can measure in the millimeter accuracy, but that will not give you the complete picture about the slope geometry or slope topography. Complete topography. And there is another approach. Majority of the problems what we have analyzed, it was 2D. It was 2D. We have summarized, we have reduced the dimension, we have only used the 2D x, y section. We negated the z. One x, y, z, z we negated. That is why all the stability what we see in the graph, nice graph, is in 2D. In 2D, generally we consider it as plane strain condition. But plane strain condition is also one kind of approximation of the reality. So people have thought of 3D slope stability through the 3D slope stability analysis. And in 3D, to analyze the slope in 3D, give rise to some complexity. What complexity? To assess very precisely the geometry of the slope. Because in 2D, you used to draw few lines to represent the surface of the slope. But in 3D, it is not sufficient. You need to plot the plane. And to plot the plane, the resolution of the point, size of the resolution, if in a good camera if you capture the surface, very precise with the microscope if you capture, you will get good amount of ripples present in that surface. So if I want to predict the amount of behavior in this surface, so the later version of the image which has been acquired by the microscope is better, because it is composed of minutest details of the geometry. So getting the minutest details of the geometry is out of the reach of the conventional surveying technique, that is still total station event. Even GPS. Using GPS is also impossible. Then people have thought of the approach. Okay, we have already developed a satellite technology. Satellite is monitoring each and every movement of human being. Why not we should also observe the movement of the block, surface topography. It will help at a one go, because satellite is moving for daily basis, hourly basis for 15 years, 10 years. They will serve you. So they will rotate from that same place after 7 days or 30 days or 60 days or 2 months. They will visit regularly. So there is a possibility that you will get data at regular interval. What kind of satellite may be? It may be polar centric, geocentric. They will visit repeatedly at that particular location, and there is some difference. So the satellite image might be a helpful tool to map precisely the thing. And there are some problem in satellite imaging, the resolution. In SAR image or multispectral lens, optical lens image, there is some problem in resolution. Nowadays we have come up in centimeter, we have come up already. In centimeter accuracy, we can easily develop the topography in 3D. It is possible. So the purpose is, if this geometry is available to you, not only that, it has a large advantage. Though slope is not approachable, suppose there is a failure you observe in a Himalayan region. Oh, the recent big catastrophe in Uttarakhand. in 7 to 8 years back, there is a big catastrophe. Big catastrophe. And if you want to assess why it has happened, if there is possibility of another failure, you cannot solve it. It is not approachable even. So you need to take care of, need to take the help of remote process. Remote process means without visiting that particular site physically, you are remotely collecting the data about the geometry. So the remote sensing basically helps you to gather, to collect the data from a distance place. How far? That is depends on the specification and depends on the technical criteria on which satellite, which sensor you have mounted. So the objective is, in remote sensing they generally send pulses, electromagnetic pulses. Electromagnetic pulses react with the soil and rock surface and revert it back. And there is another sensor in the satellite mounted in the same satellite. They will receive the reflected wave, and based on the different behavior, emitted wave and the received wave, satellite image can remote sensing. Yes. So emitted electromagnetic wave and the reflected electromagnetic wave, there is algorithm to differentiate the characteristics of the two different waves. Based on that, we can produce X, Y, Z of the, and from that we can easily develop the surface topology. That is the main. We can generate the surface. So the objective is in remote sensing, without visiting that place, remote place, you can precisely monitor at regular interval whether some information is going on or not. Even without application of remote, even without the application of numerical modeling, people have developed different kind of models to use the remote sensing image and detect the amount of changes occurred in the photograph. Means deformation analysis without considering the numerical analysis. So, remote sensing method actually a tool, very good tool nowadays for the slope stability engineers, geotechnical engineers, to take the help and use it in the field for better analysis of the problem. Because remote sensing image will give you very precise geometry about that particular place. Okay, there is some issues with the accuracy of the image. So there are some algorithms that will rectify all these errors and they will give you a corrected data set, and based on that data set you can develop the 3D. So the 3D problem is solved. So the 3D problem is solved. There are few things I have dealt with. You will go through that, you will read it, you will get the material. This is one case study I am going to show you. This is in Iran, in the National Highway 15. There are different behavior of the rock slope, and they have done a very good job. They have done a very good job. It is a recent study. It is published very recently, a few months back, in 2019, in the Journal of Geological, some geological engineering, I forgot. They have done a very good job applying this remote sensing method to determine the amount of displacement observed in this kind of hilly slope while there is a road. So they have done a very good job using the remote sensing methods. I will deal with our work after that. This is basically the approach generally we are think about in this method. One is the methods, which type of method you will apply, and which type of monitoring system you will apply, whether it is a satellite image, whether it is a spacecraft image, or a drone image, or it is a instrument. It is called in mining. It is called slope stability radar. Slope stability radar. SSR. Slope stability radar is also a one kind of instrument. It is regularly sending pulses and getting reflected wave, and they are calculating in their machine, and they are going to show you where there is a concentration of information. Though it is in a limited case, it can take into account of 100 meter by 100 meter slope phase, not more than that. But satellite image can take at a one go 1 kilometer by 1 kilometer, even 6 kilometer by 6 kilometer image at one go. It is possible to capture. It is also remote sensing methods, but there is an advantage and disadvantage based on that. So we have to mix. We have to put together all this approach: modeling approach, numerical modeling approach, data collection approach using the new remote sensing method. Then there will be approach which algorithm you are going to follow, so that will result you to the desired accuracy which you sought for. This is basically a flow chart. Will tell you, it will guide you to do this kind of similar study in your cases, in your field. If you want to follow, this flow chart will pretty well guide you what you should do if we want to club together remote sensing image and numerical modeling. This is a flow chart. Then in pitch slope characterization, there is a very important part we are going to discuss. That is no image I put together. In the image, in the last few classes, we have tried to discuss with the joint asperities, persistence. So nowadays, using computer vision technique, means image processing technique, it is possible if you capture n number of photos, maybe of satellite, maybe of normal camera or IR sensor camera, whatever, you are going to predict. Most probably Gracili was showing some slides that there is some concentration of joint set. It is based on the image processing. It is also an application of the remote sensing. Using this analysis, discrete fracture network (DFM) has developed, and it is working fine. Though numerical methods is there nowadays, computer vision technique is available with you. You can apply that method and you can determine what is the major orientation of joint along which plane and which direction. Based on that, you can classify the joint set population. So the image will not only give you the 3D, will also give you and also will characterize the type of the joint set present in the rock slope. So that is one of the major applications nowadays going on. Depending upon the joint persistence and the length and the spacing, applicability varies. Now I will share you one information. This is our recent study we have done, applying the LIDAR based terrestrial laser scanner. Already this machine is available in the market. Price is in the range of crores. But we have developed an indigenous product in our lab last year using the LIDAR that will collect point cloud data. If you put the machine here, they will rotate and they will collect the 3D point cloud of the buildings, and from that data set you will put it into a software that will develop the surface. From that you will develop the 3D. Everything is possible. And you also can do that. though accuracy matters. But if we work hard, if we apply some very good algorithms, accuracy may be very good for a short range. So this terrestrial laser scanner nowadays, people are thinking about to mount in the drone also. Because in drone generally there is a camera, they are capturing camera. We are also working with another research scholar to develop the 3D of the mine. At one run or two run, drone will travel and all mine will be mapped together. There will be few hundred number of photos, 2D photos, only JPEG photos. Using that photos, we are going to produce, and we have already produced, the 3D section of the 3D geometry of the mine, pit, open pit mine, dump as well as vein slope, and based on that we are taking care of the slope stability problem for those case studies, and it is possible. This is one of the major company now playing Topcon. There are Optec, there are Regal, there are numerous companies available now. Regal is now the boss in the market in India. This is the kind of things I was telling you. From the image itself, you can possibly plot what is the potential line of failure possible from the analyzing the methods using the image processing techniques. Another problem, using thermal and hyperspectral imaging technique or sensor, you can going to predict which kind of deformation or strain is developed in the rock mass, in the surface, or there is a presence or there is influence of fluid flow. That fluid flow cannot be measured in normal optical image. That can be monitored in thermal range and hyperspectral range. And one of our team member in IIT Kharagpur, they have done some studies on this hyperspectral regime of the image. Now, the problem is in slope stability, you need to take care regularly and you have to monitor regularly what is the amount of deformation, the mine, the veins, the overburden, the tailing spawn going to experience. I will show you at the last few cases we are handling, that is a big problem. That is tailing spawn environment, another slope stability problem that we have not discussed it. At the end, I will discuss our experiences. So, monitoring. Which kind of monitoring? Suitable monitoring techniques have to be adopted so that monitoring technique will give you at regular interval precise data set. Maybe sometimes possible that through your location, satellite, which satellite you are looking for, that satellite is not traversing. So you are deprived of the image of that satellite. So you need to take care of other way. So people are thinking about radar-based kind of thing. Nowadays, radar is also are fabricated in a smaller size and can be mounted in a drone. Even it is possible. One of the famous company called Einstein. I could not pronounce this rightly. Einstein is the company. It is America-based company. They have produced now. It has come in the market a few months back, 5 to 4 months, 4-5 months, and they have produced a radar sensor that can be mounted on a drone. So that will give a very higher degree of freedom to you to map the mine to the millimeter level. That is going to give you the degree of freedom. Okay, I can do everything. I can map the mine at the millimeter level accuracy. That is possible using radar. Though there are other issues we need to take care of. So these are the few machines used for. One is drone, I have already told. This is scanner. This kind of scanner we have worked for last 10 years. It was possible really, well, what is it mentioned? We have worked this kind of scanner, that is Ilris. It's a Canada-made company of the, and this is Rigger. There are some other sensor developed. So basically, using the technology of digital image processing, we are taking help of this kind of technology and taking all this image, and nowadays open source program is available. If you know Python, you can do everything on of your requirement to suit your requirement. You need not to be take care of whether I will buy commercial software or not. Nowadays open source are equally giving a very good result in the commercial one with the Python version. These are few case studies they have done recently. It was also recent study, 2019 study. This Steed is a very famous professor, probably you have heard of. He is from University of British Columbia, Vancouver. He have for a long years, for more than 30 years, have worked in the close to problem, and they have recently published their work on the application of remote sensing and the numerical. In remote sensing image, generally we apply this algorithm. It is called structure from motion to generate 2D into 3D. Okay. Then another case study by their team. This is the work they have done. They have tried to map which kind of prominent discontinuity, which kind of orientation of the joint, and based on that they have done a lot of study. This is another work by their team on the stability of the slope using the remote sensing of satellite image. Now we are going to tell you something about continuum model as well as discontinuum model. Now, depending upon the complexity of the slope, if you observe and you collect the data set of joint set and you observe that there is a too many number of joint set present in the rock mass, then you need to think what could be the possible methods or numerical methods you are going to use for this. For our case, when we have started this kind of problem in 12 years back in 2007, we are in the same situation. We have tried initially with continuum based methods, basically finite elements, but that was not suitable for our purpose. Then we shifted to the numerical method, discrete element based numerical method, that is EXC particle, and it's our purpose at that time. Nowadays, considering there are more advances of software SPM, and we are thinking to buy one product that is associated with their company, Geomechanica. It is also a FEDM product. It is combining the finite element as well as distinct element in the algorithm, and the approach is faster. So we are shortly going to procure that, and within a few months we are going to get that product. So we will start working on that product also. Though we have worked on FEDE approach. 10 years back, there is another product being developed in the market combining the finite element, because finite element have a very robust algorithm. Algorithm-wise, finite element is the best. Mathematically, it is the best. Discrete element have some problem, but due to the nature of the problem, if we can club together advantages of the both methods, combine finite element, discrete element. It was initially by Mundija and his team. Mundija and team, they are from some university in US or UK. They have developed the concept of hybrid finite element, discrete element, and nowadays evolution of now finite element discrete element method being introduced. And Rockfield, one company in UK, they have developed a product that is called ELFN. ELFN. ELFN or ELFIN or FEN. What is the spelling? We have worked on that. It is also combined. Suppose in a block of rock mass, block is intact and the other material is loose. So in between the interaction between different layers, it will be a discrete element. But within the block, it is a compact work. So there will be finite element. So combining together the approach of the FED approach, and people are using that methods for the application of the complex rock slope, particularly in mining, because mining is related to a lot of geological feature, complex feature, and there are other instruments. So, depending upon the purpose, you have to select which kind of numerical methods you are going to use. But for the operational convenience, majority of the people are satisfied with the result of continuum-based methods, and nowadays people are very, very fond of GIAN. They are using it and they are getting good result and they are satisfied. But that is I am telling, depending upon the purpose, importance of the site, you need to take care of which kind of numerical methods you are going to take care of and you are considering and you are not. So if the material is in a particular type of nature, basically friction characteristics dominates the behavior of the rock, then I think, in my opinion, I strongly I suggest that you should use the discontinuum-based discrete element methods. So these are the things you will get the result here. Discontinuum-based. These are the recent starting, not recent, 2015-14 select they have done. 2015 there, this is the result. Based on that, they have tried to plot the discontinuum deformation matrix. Using the particle flow code, they are producing this kind of failure. This kind of failure they are producing. This kind of failure they are going to produce. This kind of crack they are going to produce. That is what we have done in 2010 using the particle flow code. We will show you this kind of the approach. Different teams throughout the globe, they are working on that, and they are giving a very, very, very good insight about the behavior of the large rock mass, which is very, very particular in nature. These are the flow pattern nowadays used by different teams using particle flow code, and this is our product. We have published this in 2011 using PFC code to produce the there is, you can see there is a discontinuity that we have assumed. So based on that, we are able to predict the amount of crack, and it was in the range of 4 meter more or less. That is actually happening in the field. This is all what I want to say. Oh, I forgot. Before finishing that, I just want to go through a few glimpses the complexity of the rock slope we are facing in mining, particularly to address the tailings pond embankment structure. This is the recent work we are handling for the tailings pond. I will show you how dangerous it is to handle this kind of large slope. This is the iron ore mine having a tailings embankment height is in the range of 40-50 meter, I think, height of the embankment. You can see there is some crack is already developed along this line. I will show you the photographs. These are the tailings material. Where they are dumping regularly the tailings produced from the mine, iron ore mines. And along there is a embankment wall, and outside there is a forest. So this is a drain. There is a drain line in embankment. Beside the embankment. This is the kind of road we are going to see here. What is it there? Yes. You can see the crack developed along the embankment line just beside the tailings material. You see the crack is developed. You don't know the depth. But these are the things we need to take care of. Why this kind of? Because crack is developing along this line and regularly people are used to travel through this road. Not only that, vehicle used to move through this, heavy dumpers. So if there is any problem occurs, a flow kind of things will slide everything near the forest. So it is a big economic loss you are going to face for this kind of people. See, this kind of large amount of depression observed in the embankment. See, I was standing here. It is a very dangerous one. We went for investigating what is the reason behind and give the possible solution. It is a very, very risky job. To see, anytime we can engulf in the mass of morals. So these are the problems we need to take care of. In actuality, we are standing in this kind of slope here. There is a loose paste type material and there is kind of fracture developed along this line. So this is all I want to share with you. Now you are free to ask me question. Don't frustrate me. Okay. I am relieved in one way because my responsibility is over in the course, because tomorrow I have again 5 hours course for my regular GIAN PG program. So you can ask me any number of questions. I am free. I am relaxed. Yeah, तुम कुछ क्वेश्चन नहीं कर रहे? You may ask question. You will not ask question? So should we stop here? Yeah, that is the answer. Because they do not want to linger a few minutes even. Because if they question, then some time will be taken, they have to stay here because it's a punishment for them. Is it so? Okay. Thank you to you all. One observation I have. Have you told them? Okay. I was thinking to prepare the analysis as an engineer who is dealing with the problem. There is a problem in the display. It's not clear.